Good morning and hello everyone. We've had a wonderful start to the day with some very rich talks on how data is being used in journalism. This is okay. On how data is being used in journalism, and I'm going to take a slightly different approach to this and largely talk about how what the work we do at Nutanix and how we try to bring up the practice of visualizations in that. So, firstly, let me try setting up some premise about myself and the kind of work we do. So, hello everyone. As you've already known, I am Hardik Chandrahas. I work as a designer at Nutanix. For the recent past, I've been involved in designing experiences for the cloud infrastructure world, tackling challenges that deal with large scale of data, require optimized performance on solutions, and all this with super complex, involved, and integrated workflows. While this looks and sounds complex or slightly involved, the story is slightly different on how we've done this as a practice. In today's talk, I'll shed light on how visualizations help navigate this chaos and how, as a discipline, it needs to be nurtured to grow optimally. But first, what is this term Nutanix that we are seeing? Nutanix, consider it as a cloud infrastructure provider, helps IT teams manage their setup. That is largely their clusters, hosts, basically your machines on which you run your applications, your web applications, your products, etc. And we focus on designing experiences which range from sizing your requirements, getting an estimate on how big your cluster should be, to even configuring them, deploying them, and then once deployed, you have to monitor them. So that as well is what we do. I know this sounds as enterprisey as it can get, at actually a level above, but let me stress a little more on what sets this domain apart. The enterprise domain consists of workflows that integrate with a lot of other products, east and west. They operate around large volumes of data and have varied types of data. What does this lead to? Building a complex web or an array of information, and at the end, you require highly skilled folks in order to use these systems. And to add to this, something that I'm going to stress upon heavily going ahead is your engineering architecture and the implementation logic, which by the nature of the large data you have defines of how a lot of your solutions are going to be rendered. The large and varied data that we spoke of comes largely in two flavors. Consider this as a sample data set I'm showing. This is like a 1% or 1% of the scale we deal with. And one end, at level one, you have metrics generated by the system, considering your usage of resources, your performance, how fast your data is being written, what is the delay, how many operations can you do per second, what is the health, are you compliant, etc. On the other end, you have the entities themselves that generate this data. Same things, the servers, clusters, disks, your machines, your storage arrays, etc., that all generate this data. The integrated workflows that I touched upon require us to look at the relations between them in the level and also across these levels. So you're trying to diagnose from one level to the other, from one metric to the other. But why do we need this? Who's even asking for this? This comes because if you consider the journey of using our products on your server or your infrastructure, there are different points in this journey. And different user personas require different things all along. On day zero, when you're just installing your software or a software on your hardware, you might wonder, and IT admin might wonder, hey, how do I know if I've configured things correctly? One setup, on day one, they might wonder, okay, this looks good, but how do I ensure that the health is up and running? And much later, on day two, the same operations admin or say someone from the support team might say, like, I'm seeing a glitch, how do I resolve this? All good story, but how does Viz help in this? So prior to say like GUI or even like basic visualizations, users would rely largely on CLI, command line interfaces, to do all of these operations, and you would have to rely on a bunch of people and the information being shared around. Visualization acts as a tool that helps to bring order in this complexity of data and varying demand list. Now, with example, let us consider the same journey again. You have your day zero scenario when you're trying to configure something. Visualizations can help provide visual feedback as you define an entity or a workflow. On day two, when you're trying to monitor something, It provides a guided and an insightful overview, plus up-levels some key patterns and insights as well, or trends. And on day two, when you're trying to troubleshoot, it helps identify and resolve issues, aiding quicker decision making, and sometimes even helps to forecast the usage and how long you're going to last. I'll go through these buckets one by one. Let's look at the first bucket, configuration. Yeah. Day zero, configuration. It largely, as I said, it guides on configuring or defining the workflows. It provides feedback, sets expectations on your progress, errors. It also helps understand the system topology closely. Consider an example. What we are seeing a configuration workflow of something called as a load balancer, which is nothing in layman terms like a traffic cop, which is just trying to redirect your traffic and maintain the systems running fine without overloading anything. Considering it's networking, you will need a bunch of things. You would need IP addresses, you would need the port values. You'll also need to know how your internal network versus the external network exists. Visualizations help to do all of this by providing information at the right time and showing it visually as you're configuring along the way. Consider another example where you're trying to set up your object store, which is nothing but a bucket or drive to store your data. It helps to raise validation along the way, run check and say or up level, hey, some pre-checks have failed, kindly investigate before you deploy. Because in the absence of this, the system might fail. And if not here or done visually, this comes up later as an alert to the system. In yet another case, it also helps to scale from say one single entity to multiple entities architecting an entire application. It helps to see the differences and visualize the dependencies between them, which helps to understand how information is flowing through. And lastly, it also helps to understand the sequence of a single or connected workflows like a run book or an action book of sorts. Now, once we have configured this, we also need to monitor it. In terms of monitoring, what you're trying to do is basically observe the configured state in its status or health across time. You start by giving a snapshot of the system and you provide summary and some high level insights. So the most basic examples that we've used and seen are say like some high level dashboards that we've had, which give some top level numbers on insights, show distribution of patterns, show points of data at current time But apart from this, it also enables you to say dive down on a large set of data into one specific vertical. Say you're trying to dive deeper from an overview to individual pieces and analyze via filtering, grouping, or even just providing a summary on the right side. If you're not diving deep, apart from this, we also use visualizations to highlight relations and interdependencies between entities in the system that allow you to receive insights to troubleshoot further, which, as I was saying earlier, is the next sequence in this step. So what does troubleshooting actually help you? It helps to highlight differences from a healthy state. It aids the user to diagnose issues and also draw inferences or correlation between certain metrics. So consider this system wherein I'm showing you a snapshot of how a server looks and how we are monitoring the incoming and the outgoing traffic. We've clearly highlighted what is healthy versus what is not. But going a step ahead, it also allows you to filter things going upon, highlighting the actual input points, and then guiding the user to either a distilled set of data or taking actions on their next steps. Sometimes the next steps could also stem from what is missing. For example, you're seeing a grid or an array of clusters here, wherein some of the network connections are being dropped. So by hovering, you're showing, okay, what is missing in the information here? What do you need to do next? And then you can expand to see, okay, how many other clusters have this same problem? And finally, once you try to drill down a problem, it shows you, okay, what are the categories or what are the policies that are missing, and what actions can you take next. So in a way, we use visualizations to highlight the system state and then take the user to a certain defined course of action that they need to do. One of the last cases in troubleshooting is it also helps in forecasting your calculations, like estimating when my resources will run out, how long they are going to last. This helps a lot in planning your usage and your budgeting in how you want to use your setup. And also analyzing, say, over a time period scale of how exactly my resources are being used and when has an issue arisen. So correlation also is something that we enable our admins to do. Now that we've shown a bunch of these examples, I'll move next to the process of how we actually do this and what is the design and the development process of this. And what are basically the key highlights for us at Nutanix. Yeah. First, the most important question is to figure is Viz even needed? Like, let's not throw it at every problem at we see. You have to figure out is Viz the best suited route for this? What is the impact derived from the solution? What happens if we don't use Viz and we use simple lists in here? And if the problem is solvable, then great, let's not use Viz. But in cases, how we do that is we try to write, say, like user stories or larger problem statements for the key problem we are trying to solve. And from that, then evaluate key tasks and needs and highlight what are the key information points that we need. And based on certain actionable points, we decide, okay, this is something that visualization can clearly help with. Once we have that, we try to get all possible range of metrics, variables, and their possible range of data values. So unlike your regular data analysis or visualization, we need not necessarily start from a full-fledged data set at the beginning, but we can start by knowing what is the possible range of values. This helps to set up how much the system can stretch and where will it break. This is something that I'll stretch upon going ahead. Next up, you start iterating it piece by seeing how each of these charts are trying to communicate what was the largest story. And also you try to say, build and review these things with engineering. But now you're trying to get a sense of what is the larger frame trying to do, how will the user's course of action look like. And more importantly, as I said, this is when we start to get involved with engineering because a lot of these things are going to get shot down because they're either not performant or they require multiple calculations to be done, and that would increase latency to the user. So how do we go about navigating those? First things is to get an idea of the scale or start testing these things on the scale you're working. One of the things that we do here is to look at, say, like the adoption data or the telemetry data that we have and get a sense of what is the distribution of customers or their setups according to whatever problem you're solving. Say, like the number of clusters that you have. Your visualization needs to hold differently on each of these points, and you could use intelligently design principles to do that. We consult heavily with engineering on their API model as it influences many decisions on failures that I'm going to talk about and even other performance implications. As you see, how we've highlighted or have tried to highlight cases when you have, say, one cluster to many, to 9 to 20 and even beyond when you have, say, like triple digit number of entities. And all this, yes, requires co-building with engineering because your APIs also need to follow the same order of how successively you are going to call them. And what do we learn from these engineering discussions? One of the key things is, say, like how is the data structured today? Is it a single table or are there multiple tables? Because if it's a multiple table and you try to call all of them together, it might bring about a lot of latency. So you show like a trend first and then you deep dive later. Next up, how do you tackle successful versus failed call versus data that is already available versus what you need to derive. In case something fails, we need to give some feedback and provide on how it is done or handled actively and what can the user do next. In these cases, either retry or file a support ticket. Moving forth, while we are talking about like how your data is structured, we also talk about now how is the data fetched. If your larger pane has single or multiple charts, you might see multiple loading bars behaving independently. Or if you're fetching large number of data points, your engineering might get back to say, hey, this is not possible in one go. You'll need to batch this. So in those cases, what we try to do is experience-wise, can we handle this? Just a second, I'll need to move. Yeah, I'll play. Yeah. So in these cases, as you see, we'll try to load them in batches, at the same time giving the skeleton loading experience to give feedback on how many of them are done versus how many more do I need to keep doing. This at least sets the expectation that the system is not glitching and you're seeing things step by step at once. Moving forth, once you have developed, now you need to start assessing what you have developed. Is it at least on the right track or not? So to start off with, we start doing some qualitative surveys with people, understanding of what their sense is, how they're responding to it, and we try to then derive what our next steps of evolution should be on this. Once released, it's quite straightforward, wherein we dive deep into telemetry data and also try to look around what is the adoption around it, how are users interacting with it. The idea here is that your whatever viz or analysis skills that you applied so far would also help you here to analyze and visualize how the feature has been adopted and how, say, like the user has been interacting with it. All good so far. Sounds like a very nice linear story that all of us wish. But in mid to large organizations in enterprise, you often have a plethora of forces beyond your control that can impact you on a second order basis. Something that you didn't even imagine might end up completely derailing what you're working on. Changing org priorities could lead to, say, certain pivots in your direction. So how do you nurture Viz in those conditions? Let's look at what the org needs and how Viz can get around doing it. See, the emphasis of the org would be to get things out first, improve later. At something that happens in very large scale or even mid-sized companies is ship something just right and improve later. With Viz, the right bucket is just wider because your Viz has more chances of failing across the kind of setups that people have. So Viz ends up facing scope cut. There is a preference for features with higher impact, and visualizations require higher investment because it has wider needs and requires stronger stakeholder buy-in because it takes time and effort to build that. How do you tackle this? You build with stakeholders, with your engineering and PM, keeping them involved in every step. But more importantly, you learn to prioritize and pitch things in phases. It is one thing to design something blue sky, but you should be able to trace it back to where you are today, break it down into phases, and then work towards it incrementally so that your solution keeps holding true at each point. Next, every business wants to maintain stance with its competitive offerings. In terms of this is quite straightforward. You could do competitive analysis by evaluating how your competitors are doing and how are they using Viz to solve their problems. Helps to build a very direct case. But more importantly, it becomes difficult to figure time for Viz amidst all of this regular work. Because your bandwidth and your priorities would always be on, say, the key features that you need to deliver. How do you tackle this is whatever learnings you have so far from previous efforts, from competitive studies, you evangelize the findings and the value with your senior leadership, your management, and say like your heads of departments. You, more importantly, try to componentize patterns, build a library of sorts as much as you can do, so that if anyone else wants to try and build doing this, they have a path to follow and they can try to quickly implement rather than trying to reinvent the wheel again. When I joined this team, my company Nutanix around 4 to 5 years ago, after my master's in information design, data visualization from college, little did I expect it would be such an impactful and insightful journey going ahead. My journey in college was largely inspired by some of the talks that you saw in the first half, just the two talks before me, wherein I drew inspiration from print and interactive viz media and journalism. And I would do visualizations based off on a story or trying to figure a small series of questions. It worked, it ended up being completely different, but interesting in many ways. It started off with designing smaller individual charts, which soon grew to addressing large scales of data, wherein you're trying to work around engineering implementations on a solution, figuring out what will go, what will not go. First things that you hear when you're trying to work in a large org, because in college you end up doing everything from scratch by yourself, and there is no for an answer there. It ended up even going into, say, analyzing adoption data that I spoke about and evangelizing the need for Viz amongst in the company and outside. I would say it's been an enriching experience for me all around. And I hope this campfire, which we are all here for today, continues to stay lit in the years to come by for all of us, for me, and even at work for Nutanix. And yeah, that's all, folks. Thanks for being a patient audience, and do come over to our booth. We are on the first floor, right outside the exit, and you can come chat with us, get to know more from our wider design team who's here today from Nutanix. Yeah.
We have we have time for a few questions. Does anyone have any questions for them?
Correct. Oh, yes, yes. That's a very common scenario. Like the senior leader has a vision of what they want the visualization, because they're looking at from the perspective of a pitch deck. They're looking at from the perspective of a demo. But the actual thing that works for the user might be completely different. So in these cases, while even I have started on that route by building what, say, the exec wants, what we try to do is, as we are building it, we try to evaluate as widely as possible with our set of, say, support folks who interact with customers or with customers themselves, and try to build a case of if this is on the right track or not. And if, say, the pursuit still goes on, we still want for the demo, then we say agree to disagree to do a demo version versus something that goes in the product. So that's like a fine line to thread, but yeah, that is one way you can take.
Anyone else? Yeah, there at the back. We
You
can bring
should
the
get a
mic to you, but
mic.
you can say maybe I can repeat the question. Yeah.
Okay. So yeah. Okay, I'll repeat it for the wider audience. He asked, when we are doing visualizations, what sort of prototyping tools are we using? So largely, my journey stretches over a couple of tools. I'll try to, say, start with Sheets or Excel or something, wherein I'm trying to just get a sense of the scale of the data and sometimes even do a mock data set just to test my thing. Then you start by making some high-level prototypes on Figma itself to get a sense. And if need be, we also venture into observable. But that's largely with, say, the UI developers, wherein observable, for folks who don't know, is a UI library that's pretty nice and easy to use, and you can plug in your data set, or you can try to figure out specific visualization library parts that you're trying to work on. So that is something we have done as well. Yeah.
Anyone else? Good. I had a question actually.
Sure.
I was very curious. I wrote it down somewhere. Yeah. Is there a? I remember you mentioning that you have to decide what kind of Viz works for a particular situation, and does the Viz even work? What were instances where data was not a solution, and you had to actually step back from it and present the information in some other way?
Yeah, that happens on a fair bit of occasions. Say if, like, while we say visualizations help in, say, monitoring cases, but in some senses, if you're not reaching the scale that you're expecting, a simple list works. Or if you're trying to configure something that is not super convoluted, a simple form or a simple wizard could also work. So those are situations where we, say, started off with Viz, but we had to soon supplement or even replace the Viz that we designed with. All right, thank you everyone.